Hello, Algebra 3. This is our video key for 7.2. That was our lesson on solving exponential equations using logs. Our steps for approaching those types of equations is first we isolate the exponential equation. Then we are going to rewrite it in logarithmic form. Then we're going to use our change of base formula and solve for the variable. So let's get started with question number 1. Here's number 1. We have 6 raised to the 2.6r equals 58. So our first step is to isolate the exponential expression, which it is. It's by itself. We're not multiplying it by anything or subtracting or adding anything to it. So step 1, we're good. Now we need to convert this to logarithmic form. So we're going to, our base is 6, our exponent is 58, and that's going to be equal to 2.6r. Hold on, that's log. I forgot my logarithm. Okay, that's the logarithm. The log base of base 6 to the 58th power equals 2.6r. So we're going to use our change of base over here. So we'll have the log of 58 over the log of 6, and that's going to equal 2.6r. So let's calculate this here real quick. We're going to have the log of 58 is approximately 1.763. That's going to be over the log of 6, which is approximately 0.778. That equals 2.6r. I'm going to go ahead and do the math over here. 1.763 divided by 0.778. It's right around 2.266. I divide that by 2.6, and I will get r equals 0.8715. And there's my answer for number 1. Number 2, I'm given 8 raised to the 10x equals 85. So I already have my exponential expression isolated on the left side here. So the next thing I'm going to do is I'm going to rewrite this into logarithmic form. So I'm going to have the log base 8 of 85 equals 10x. I'm going to use my change of base on the left side, so I'll get the log of 85 over the log of 8, and that's going to equal 10x. I'm going to do the calculations on the left side here, so if I have the log of 85 equals 1.929 approximately, and then the log of 8 is approximately 0.903, and that equals 10x. So 1.929 divided by 0.903, that gives me 2.136 equals 10x. And when I divide that by 10, of course, I get x is going to equal 0.2136. And that is my answer to number 2. Number 3, I have 7 raised to the negative 6m equals 81.8. So I do have my exponential expressions already isolated there on the left side. So I'm going to rewrite this in logarithmic form. So that's going to be the log base 7, 81.8 equals negative 6m. I'll now use my change of base on the left side. So I'll get the log of 81.8 over the log of 7, and that's going to equal negative 6m. So let's do the calculations over here on the left side. The log of 81.8 equals 1.913. That'll be over the log of 7, which equals 0.845. That's going to equal negative 6m. So let's see, 1.913 divided by 0.845. That's going to equal 2.264 equals negative 6m. So m is going to equal, divided by negative 6, m will equal negative 0.377. That is my answer for number 3. Number 4. We have 9 to the n plus 2 equals 27. My exponential expression is already isolated on the left side here, so I'm going to rewrite this equation in logarithmic form. I will get the log base 9 of 27 equals n plus 2. We'll go ahead and use our change of base formula on the left side. I'll get the log of 27 over the log of 9 equals n plus 2. So the log of 27 equals 1.431, and that will be over the log of 9, which is 0.954. That equals n plus 2. So 1.431 divided by 0.954 equals 1.5. We're going to have n plus 2 equals 1.5. We subtract 2 from each side. I'm going to get 9 equals negative 0.5. That is my answer for number 4. Okay, number 5, we have 8 to the p plus 5 1 power minus 7 equals 78. So the first thing we need to do is we need to set our exponential expression. We need to isolate that over here on the left. So we're going to add 7 to both sides. I'm going to end up with 8 to the p plus 5.1 equals 85 after adding 7 to both sides. Now I need to rewrite this exponential expression or equation into logarithmic form. So I'll get the log base 8 of 85 equals p plus 5.1. Use change of base formula over here on the left. I'll get the log of 85 over the log of 8 equals p plus 5.1. Let me grab my calculator here. We'll figure out the numbers on the left. The log of 85 is 1.929. The log of 8, 0.903. And that's going to equal p plus 5.1. So 1.929 divided by 0.903 equals 2.136. So 2.136 equals p plus 5.1. I'm going to subtract 5.1 from each side, and I'll end up with p equals 2.964. And there is my answer for number 5. Number 6, we have 20 raised to the negative 6n plus 9 equals 102. We need to isolate this exponential expression on the left side here first. We're going to do that by subtracting 9 from each side. So I will get 20 to the negative 6n equals 93. Now I need to rewrite this in logarithmic form. So I'm going to get the log base 20 of 93 equals negative 6n. I use my change of base formula on the left side here. So I'll end up with the log of 93 over the log of 20 equals negative 6n. So I'm going to grab my calculator. We'll figure out these logs on the left side. Log of 93 is 1.968. The log of 20 is 1.301. And that equals negative 6n. 1.968 divided by 1.301, that's going to equal 1.513 equals negative 6n. So let me divide that 1.153 divided by negative 6 equals, so I'm going to have n equals negative 0.252. And that is our answer for number 6. Number 7, we're given 7 raised to the r plus 2 plus 6 equals 22. The first thing we need to do is isolate our exponential expression. So we're going to subtract 6 from each side. So I'll get 7 to the r plus 2 equals 16. Next, I'm going to rewrite this in logarithmic form. So I'm going to have the log base 7 of 16 equals r plus 2. Then I'll use my change of base on the left side here. So I'll get log base up. The log of 16 over the log of 7 equals r plus 2. So I'm going to grab my calculator so we can figure out these logs. So we have The log of 16 is 1.204. And the log of 7 is 0.845. And that equals r plus 2. So if I do the calculation, 1.204 divided by 0.845, that will equal, I'll bring that up here, 1.425 equals r plus 2. So if I subtract, let's see, 1.425 minus 2, my r is going to equal 0.575. That is my answer for number 7. For number 8, we have 12 raised to the 7n plus 6 equals 8. We need to isolate our exponential expression there, so I'm going to subtract 6 from each side. I'll get 12 to the 7n equals 2. Next, I need to rewrite this in logarithmic form, so I'm going to log base 12 of 2 equals 7n. Use my change of base on the left side. I'll get the log of 2 over the log of 12 equals 7n. So I'm going to grab my calculator so we can figure out these logs on the left side. So the log of 2 is 0.301. The log of 12, 1.079. And that equals 7n. I'm going to move over up here to the right side. So 0.301 divided by 1.079. That will equal 0.279. That's equal to 7n. So dividing each side by 7, I get n equals 0.0399. And that is my answer for number 8. Number 9, we have 7 times 13 raised to the 6n equals 76. I need to isolate my exponential expression over here, so I'm going to divide my left side by 7. Well, I'm going to divide both sides by 7. So I'll get 13 to the 6n equals, 76 divided by 7 equals 10.857. Now I'm going to write this in logarithmic form. So I'm going to have the log base 13 of 10.857 equals 6n. Use my change of base formula over here on the left. I'll get the log of 10.857 over the log of 13. That's going to equal 6n. Let me grab my calculator here. We'll figure out these logs. Log of 10.857 equals 1.036. My log of 13 equals 1.114. That equals 6n. Move over here on the right side. 1.036 divided by 1.114 equals 0.9299. And that will equal 6n. Now I'm going to divide both sides by 6 so I can figure out what n is. So 0.9299 divided by 6 gives me n equals 1.549. That is my answer to number 9. That brings us to number 10, our final problem on this assignment. We have 14 raised to the negative 8.9r minus 2 equals 42. Well, first I need to isolate my exponential expression over here, so I'm going to add 2 to both sides. I will get 14 to the negative 8.9r equals 44. I'm going to rewrite this in logarithmic form, so I'll get the log base 14 of 44 equals negative 8.9r. I'm going to use a change of base formula on the left side, so I will get the log of 44 over the log of 14. That's going to equal negative 8.9r. I'm going to grab my calculator. We'll figure out these logs. Log of 44 is 1.643, and the log of 14 1.146. And that's going to equal negative 8.9R. Let me do a calculation on the left side here. 1.643 divided by 1.146. That equals 1.434, and that equals negative 8.9R. I'll move everything up over on the right here. I'm going to divide each side by negative 8.9. So 1.434 divided by negative 8.9 is going to give me R equals negative 0.1611. There's my answer for number 10. R equals negative 0.1611. So hopefully going through these examples helped you out if you were stuck on any of these problems, or maybe you saw what you did wrong, maybe you were to correct something on your work. If not, please email me so we can work that out.